because that out of 5 and at 1 it's completely 0. Yeah, and then we get, we're using these. Oh no, we'll use these one. Does it matter what one?
So we'll probably need to do a few of them anyway.
Yeah, we'll have to get them.
So if you were doing that blue one,
we'll do that right there,
yeah.
which is up 1.5 and across 1.
Okay. So its gradient would be, is it? So its gradient would be up 1.5 across 1. So its gradient would be
1. Right.
and a half.
Yeah.
So when x is 1,
Yeah.
the gradient is
1.5. Oh, it's not much bigger than that one. It's there. And therefore the negative, or the other side of it here,
yeah.
the negative side, will be here. So it's at, yeah, it's at a half. Because it goes
What's the gradient of this?
across -1 and up by a half.
Sure it's up by a half?
Yeah, it makes it.
So where's the other point on that tangent line that you're using to work out its gradient?
There. Oh, so should we use...
No, you've got to use just on the orange line now. Yep.
Yeah, we'd use there, wouldn't it?
Yep, and you need another point to get your gradient.
Up there.
Cool.
So,
So it's definitely across 1.
and
how far up has it gone?
it's gone negative... Oh, -1.5.
Yeah. Is it going negative or is it going positive gradient?
It goes positive. If we count from here, it goes positive. But if we count from there, it's negative.
So it's either it's negative negative or it's positive positive. And so the gradient itself will be?
It will be positive, right?
Cool.
Because 2 negatives are positive.
And so when x is -1, the gradient function is, or the gradient is positive 1.5.
So that's why here it will have to be up again, won't it?
Yes.
Meaning it will be a parabola. Or looks like it might be. Because they're coming up. Because it's not a straight line.
Cool. When x is 0, what will the tangent look like?
So there.
So we're looking at the red line. So when x is 0,
It's specifically 0. Or 1. Isn't it? Because, yeah, 0.
so its value is 1, but its gradient is
0.
Cool. So when x is 0, the gradient is 0.
Yes, that should be there.
Yeah.
But I'll put that there by accident.
So at the moment we've got that point, and that point. Yep. Do you want to work out, so the gradient of the green one?
Yeah. So it looks like it will be there, is the middle of it.
Yeah.
So when x is 2, y is 5. So for every... Oh no.
Yeah, that's a bit of a nasty one,
Yeah.
isn't it? Because it doesn't go through anything nice there,
No.
particularly. So what say we took it all the way down to this point down here and looked at that.
So that's -7. So for every 2 it goes across, it goes up by 12. And then for every 1 it goes across, it goes up by 6.
So when x is 2, the gradient would be
6. So when x is 2, the gradient will be right up there.
And this green one and this blue one
Parallel.
are parallel, so they will have the
Same.
same
Would it
beginning.
be on the other side? So it is parabola.
Cool, so
And
draw
then
it in.
from the parabola, can we take it to a straight line? Or do we leave it at a parabola?
Okay, so draw that one in.
Mhm.
That parabola describes the gradient of this cubic.
Okay.
Yeah?
Yeah.
Now, if you went to the next step and got to a straight line from the parabola, that would be describing the gradient
Of the parabola,
of this one.
not the
So it's
cubic.
like the gradient of the gradient.
Yeah.
So in terms of calculus and studying rates of change, this is describing the rate of change of this. This is describing the gradient of this.
But we're still x squared here.
Good.
So
So it's an
that's
x
one
squared.
So would it be x squared 2 or 2x squared? Because for every one it goes, no. Something a little different than that.
So you know it's got something to do with x squared.
Mhm.
Cool. Do you remember how to get equations of parabolas? We know it's going to be something like that, and we know it's not moved up or down, it hasn't moved sideways, so
Yeah.
there's not going to be anything over here,
No.
pluses or anything on it. The only thing it could have is,
And I don't know which describes, because the normal parabola, I remember, was pretending that's 0. It was like 1, 1, and then it became 2, 2, and then that's how it went on the other, and that's just x squared.
yes,
But it's not that, it's slightly steeper than that. Is it 1.5 x squared?
alright, write it down. And how could we check it out? We know this point, don't we?
Mm-hmm.
What's that point?
6 over 2, but 2, 6.
2, 6, yeah, that's the point. So when x is 2, the other part of the gradient is 6.
Yeah.
So if we put 2 in here for x,
Mm-hmm.
would that turn out to be 6?
2 squared, 4. Yeah, it would. Because x squared would be 4, and 1.5 times 4 is 6.
Awesome. So you've now got a gradient function that says 1.5 x squared, and it came from,
1.5 x cubed.
well, it came from half
Oh,
x.
half x cubed.
So what do you think's going on with that power?
The x was almost like an entire 1. Like it. And when we took that out, I feel like it just became a whole. Oh! Well, this was times. That's technically times by 3. The half function is times by 3.
So it's times by its power.
Yeah.
So that and that seem to be timesed
Mhm.
to give you that.
Yeah.
And the x drops the power.
Yeah.
Does that work with these ones that we already had us work these ones out? If you,
Times this by the power.
yeah,
3/4 times the power equals 6 over 4, which is 3 over 2, and it drops the power. Yeah.
and this
This-
one,
It got times by 2 because it was technically negative 1x, and that got times by 2, so it was 2 over, or negative 2 over 1x, and it drops the power. And we completely ignore the plus, don't we?
yeah, because what does that plus 3 do to a graph?
It just moved it up.
So it's not going to change its
Gradient at all.
gradient at all.
No.
Oh, brilliant.
Perfect.
So could you describe to me, if I gave you any function at all,
Mm-hmm.
what you'd do to get a function that we call a gradient function, a function of what's happening to the gradient.
Yeah.
What would it be?
U time whatever is sort of being times by the x, whatever, squared or cubed or anything. You times it by the power, and then you remove one of the powers and you ignore the thing that's talking about the y-intercept.
So if I gave you something that you don't know what it looks like, if I gave you that, what do you think its gradient function might look like? You know most of what the beginning of calculus is about.
Are you going to take it, Sophie?
Yes, exactly. I think that's where we will stop.
Yeah.